Hello friends. Yeah, today I'm going to explain basic concept of Docker. What is Docker and why we are using in the current uh, infrastructure management. Actually, this initial basic class actually to explain, make understand people like how to build the Docker image and push to Docker registry, and so that can be used in the container orchestration like Kubernetes. So this is completely basic, just to start with whatever knowledge I have gained. Maybe I'll improvise, try to improvise in the next session. This is not planned as a planned session. I'm just try to explain it to people. So also share some hands-on session so people can get understand quickly. Thank you.
That they're creating a virtual instance, uh, and above that they're creating a services like a server, storage, and network, everything in virtual environment. And they started using those virtual machine to deploy the application instead of 10 different boxes. They're running everything on a single virtual environment, and top of that they're creating a multiple VMs. So that is also a more tedious task, and creating it in every time and require a more resource to run those virtual machines and all. Then the latest version, they what they thought that they can OS level virtualization they start, like in the OS level virtualization, like from the virtualization where the kernel allowed to create the isolated user space of the containers, like in top of the uh, single OS, they can run multiple containers using Docker. The Docker comes in a picture. It's an open source tool which allow you to run a multiple container with a device. And if you come to VM, it's a hardware level virtualization. And isolation comes to VM, it's a complete OS will be isolation, but in the process level, only process will be isolated. And performancy, Docker will be a faster startup time and lightweight. And in the virtual machine world, it will be heavy and slower startup time. The application brings up time will be taking more time. And resource utilization, minimum footprint, and shared kernel. And in the virtual machine we should have a dedicated resource per VM. And minimal will be like it will use the minimal CPU and memory consumption. If we come to the virtual machine, it will require a more CPU and memory to bring up the things. As a Docker is a tool. It's not a any kind of a image. It's a tool that will help you to deploy the application container, so the application can work efficient in the environment, in isolation environment. Like you can, if you once you build the Docker image, you can deploy that in any of the guest OS. Like if you can deploy and run on the Windows OS, or you can deploy it on the Linux boxes. Anywhere you can, once you package the image, and you can run using Docker that container in any, on top of that any of the guest OS. Okay. And if you come to the architecture wise, there will be three different, right, like the client side and the Docker host and registry. um, from client side, it's basically a CLI tool you can use. If you install the Docker in your system, there will be a CLI tool available. You can use the Docker is the command, and using Docker build, you can build the image, and Docker pull used to pull the image, whatever you build the image, all you can pull, and you can use Docker run to start the container. Likewise, in the Docker host, it's a daemon which will run your container, whatever the images you build. That images can start running using the Docker host. Inside the Docker host, the daemon will be running. And similarly, the Docker registry, you heard a Docker hub, right? You in the Docker hub, whatever the images you created, or those images you can store in the Docker registry. So later, anytime you can pull that image from the Docker registry. So whatever the images, the application specific images you build, you can keep that in a central repository. So you can pull from anywhere from your application configuration. Okay, and come to advantage, it will be a lightweight and very fast. Like the building the application, they will be using a small size of base image, and they will push all the code to over there, and it will be very fast compared to the old legacy application. The building these images, Docker images, will be very fast, and it will simplify the application deployment. Uh, since you are packaging everything in an image, and you no need to take a, if you once you define all the dependencies, the Docker will file in the Docker file, everything will be taken care. You no need to do it manually or update each and every time. Once you define it, it will take from there, and it will package all the dependencies, and portable across environment. Like you can deploy these images on any top of the any guest OS and anywhere, right? That's why it's portable across any environment. And scalability for microservices very fast compared to the legacy or other application. You can
Mhm.
scale individual service files, since we are putting in a microservice architecture. The scalability will be very easy in the Docker container. The Docker file, actually, it's a text file containing all the instructions how this Docker image to be built. Here, if you see the example, the from is the base image, which image we are gonna use to create the image. Actually, this is the base image, and Docker run is the command it will use to install any command, install any packages. For example, if you need update and install nginx package here, for that we will be using the run command. These are all the instruction we are passing to Docker file, and later we'll use this Docker file to build the image. Okay, and this command will be you. uh, Once the Docker container is up, this command will be executed first place. It will start the nginx service. Later I'll show you like one application how we can build it. Okay, and Docker volume, like all the application required some sort of volumes storage to store the application log or application related data. So in Docker also we can create a volume, persistent storage for containers to store the independent of the container lifecycle. If the container are writing some files or data or some information, that needs to be persistent. In legacy application, we'll be using the EBS, I don't know, EBS or NAS, SAN storage and all to store the application data. But in here Docker, we can use the volumes. Once volume is created, the that can be attached to the container. When we are starting the container, we can attach the volume and path. So if the container goes down, also the volume will be, the data will be persisted in the volume. So the data will be retained. If the you can install in your laptop Docker, and you can use this command to build the Docker image, and you can the second command will use it to log in the Docker Hub. If you have your own Docker Hub, create a one repository, and then you can tag this the username, your Docker username. You can replace that to your username and tag it, and you can push back to the Docker Hub. Then you can use this command to run the Docker application. Okay, Docker file is a text file used to define the steps to create a Docker image. It specifies the base image, application dependencies, and configuration settings and commands to run the container starts. Okay. The key instruction to create a Docker file is a from and work directory and copy and run and expose and command. Okay. And this the sample Python Flask application which is routing like slash. It is routing as a hello Docker by Vinay. This in basically web page it will display this thing and runs on port 8002. And the requirement.txt it will install all the dependencies. These are all the basic command which we can use. Now there's no image currently available. Using this docker build -t app, we can build the image locally. Now I have built the docker image. If you see the app and there's pointing to latest version, and to push that image to our own Docker Hub registry, we have to tag that to our username and the repository name. So what I'm doing, the app and pushing to Vinay is a username and Python app is the repository name and the tag I'm pushing to V3. Now I'm using Docker login to login my Docker registry. This command I can use to login. Here I'm providing my Docker Hub username and credentials. Now I can see it's login succeeded. Once it's logged in, now we can go and check what are the available tags currently. Yeah, is the repository is available and what is the latest tag. So I can push the new tag num instead of using the same tag. Okay, if you see the version 2 is available, now we are pushing version 3. We can use Docker push. Now, if you see the same tag to Vinay slash Python apps v3, I'm pushing Docker push and the repository Docker repository username and repository and v3 is the new tag. Is the command to push image back to the Docker registry. Now I have pushed successfully. You can go back to the Docker registry and check the image a new tag is available or not if you want. Okay, see now I'm forwarding using this port to run the container.